Okay, question 10. Okay. Function px is defined by px equal x cubed minus 3x squared plus 8x minus 24. And find the remainder when px is divided by x minus 2. So here is going to be the remainder would be p2, right? p2. So may I write it here, ai here? Okay, ai is going to be p2. So you just write down, you replace every x you see by 2. So it's 2 cubed minus, I should write it in brackets, 2 cubed minus 3 2 squared plus 8 times 2 minus 24, which is 8 minus 12 plus 16 minus 24. Okay, so you have here this is 24 and then minus 24 gone, so you have minus 12. Okay, ai remainder is p3, right? So 3 cubed in brackets minus 3 and 3 squared plus 8 times 3 minus 24, 27 minus 27 plus 24 and then minus 24, which is 0. What does it mean? P3 equals 0. It means the remainder of the px divided by x minus 3 is 0. So no remainder, mean x minus 3 is the factor of that px, right? Okay. And then B, prove that px has only one real 0. Okay, what does it mean, one real 0? One real 0 is like if you draw a graph of px, you're gonna get one real 0, one x-intercept. So here, suppose this is your graph. It must be cut here, just only once. You cannot like go back down here and cut x in x-axis one more, no. So it means you have go up for all along, or you may go down, all along and cut only once. All right, so once there is no turning point, so no turning point, it means your gradient doesn't change. When the gradient doesn't change, no turning point. So we're gonna analyze it from the gradient of p prime x. All right, okay, p prime x. Here, b, we find p prime x first. So you have 3x squared minus 6x and then plus 8, right? We are showing that there is no turning point. Okay, to show there is no turning point, so you have to show this graph. If we can plot it, this graph, you can see it's quadratic graph, right? It's no turning point. Or you could say this word, you could say we have to show that gradient or p prime x doesn't change the sign, right? If they are positive, it's positive. If they are negative, or negative for the gradient of px or p prime x. So it means if you plot this graph, all right, all of this graph must be above x-axis because all values must be the same sign, right? Or it could be all below x-axis. But this one, is this above or below? Just take a look on x squared. It's positive, right? So all above. So this is what we expect. It's all above x-axis. So to show that this one is all above x-axis, you have to show discriminant of this one is less than 0, right? Because, okay, let's talk about discriminant. You have three values, greater than 0, discriminant greater than 0, discriminant equals 0, and discriminant less than 0. If discriminant equals 0, it means you have one real root, one root. If discriminant greater than 0, it means you have two roots. And this one less than 0 is mean no roots, no root at all. So this one, all above x-axis, no x-intercept here, no x at all, so no root. So we go for discriminant less than 0. So what do we have to show? So we have to show discriminant equals b squared minus 4ac, right? So your b is minus 6 in total square minus 4 times a, which is 3, times c, which is 8. So it's 36 minus 96, which is minus 60. So you're going to conclude that since discriminant is less than 0, so p prime x is all positive. So that is no turning point on px. So and as we know the root of this polynomial is x equals 3. You have one root already, so there is only one real root. All right, you need to conclude it as there's a mark here, at least one mark. All right. Okay, we finish question B, and then we go for question C. Write down the transformation that will transform this graph y equals px onto the graph, the new graph. Yeah, that one. So we have to rearrange the new graph to see what would happen. Okay, we can observe. Okay, I would observe from this one. How can we change x cubed to be 8x cubed? I would say I would change every x I see here by 2x. I replace it by 2x. So here from px, I'm gonna do like it's from 2x cubed plus 3 2x squared plus 8 2x, and then plus 24, right? When you simplify it, you would get this number, right? So your y is transformed the px by change x to be 2x. So it's called stretch, horizontal stretch. Okay, horizontal stretch by scale factor. Right now you change every x you see to be 2x, okay? Because of its x, so it's horizontal stretch, and because of number 2, so scale factor is 1/2. All right, and then last question D. The random variable x follows Poisson distribution with the mean of lambda and follow the equation. We have to find lambda. Here we have to look back into our formula booklet. What is Poisson probability? Here, if x random variable x equals small x, the formula would be lambda to the power of x times e to minus lambda over x factorial. All right, so we replace it in. So 6 here, and then right now your x is 3, so times lambda to 3 times e minus lambda over 3 factorial, 3 times lambda square e to minus lambda over 2 factorial, minus 2 lambda square e to lambda to power of 1, which is lambda, and e to minus lambda over 1 factorial, and last one plus 3 lambda to 0 e to minus lambda over 0 factorial. All right, and then we simplify. Okay, we simplify here. This is 6, this is 2, this is 1, and this is 1. So 6 and 6 cross out. So I say I would times the whole thing by 2 to get rid of 2, this 2, okay? So we're gonna get here 2 lambda to power of 3 e minus lambda, 6, not 6, you times it by 2, you cross this out, right? So you get 3 lambda square e minus lambda minus you times this one by 2, you would get 4 lambda e minus lambda, and then plus 6 lambda to power of 0 is 1. So you just have e to minus lambda, so e minus lambda. All right, and then may I move everything to the left hand side? Okay, so once we move it, we're gonna get 2 lambda cube e minus lambda minus 3 lambda square e minus lambda plus 4 lambda e minus lambda, and then minus 6 e to minus lambda equals 0. Okay, equals 0. Can move a little bit to make it equal. Okay, a little bit. Okay, not the point, but I still need the equal sign on equal line. Okay, we can see this is a common factor. We can move it out. So e to minus lambda in brackets here, 2 lambda cube minus 3 lambda square plus 4 lambda minus 6 equals 0. Okay, here, because of this is the last question, is question D. I suppose that we can use some previous information to solve this one. So I like to look back. We have this and we have this, right? So which one is look familiar with this one, the first or the second? So let's check. We have 2, 3, 4, 6. Here, if we times this one by 4, you will get this, right? Yeah. See, 4 times 2 is 8. Yes, 4 times 3 is 12. 4 times 4 is 16. 4 times 6 is 24. What else? Yes. And then oh, this is another mistake here. I can find here. This is minus 24. I use minus 24 all the time except here, but it doesn't affect our work because because it does. So actually I have to change it back. I'm sorry guys. Okay, here this is minus, and here it's the same now, right? Okay, so times 4 here, you get minus 24. So here you have 2 brackets. This is the first bracket, this is the second bracket. 2 brackets times each other to get 0. It means one bracket could be 0, right? Either one of them, but the problem is this one cannot be 0 because it's exponential. So you have only last chance here. This is equal 0, right? So you have 2 lambda cube minus 3 lambda square plus 4 lambda minus 6 equals 0. And I have to use the previous information, so I times everything left and right hand side by 4. So I would get 8 lambda cubed minus 12 lambda squared plus 16 lambda minus 24 equals 0. And how can we solve this one? This one is the transformation of px, right? This is your px. Your px has only one root, which is x equals 3, right? And this transformation is horizontal stretch by this scale factor. Therefore, your px, first of all, your px is supposed to be cut at 3. Okay, cut at 3, and then when it's stretched in and stretched by scale factor of a half, this number 3 turned out to be 1.5. Therefore, to solve this equation, your x equal to 1.5. Okay, finish.